All right, hey guys, so I'm going to go over today's Bellwork, the proportion relations practice Bellwork. So this will help you if you didn't quite understand how to fill in all of those charts on this right here. If you don't know how to fill out all this, today's Bellwork will help you do that, okay? So let me walk you through that. All right, so for the first one, I know hopefully it flips when I put this on YouTube. All right, so if the average density of my red beans in my quadrant sampling lab was 12, so the average, if I added them all together, was 12, using my quadrant size of 147 centimeters squared, so that means there was 12. When I threw it 3 times, I counted 12 total, and my quadrant size was 49. I multiplied that by 3, and so I'm using 147, okay? So what would be my experimental value or estimated population be for a plot area of 7,200? So they're saying if I got 12 in this size, what can I calculate to be my amount of red beans in this size of an area? So you just set that equal. And then you just cross multiply because you're solving for x. All right, so you're going to end up with 147x set equal to, let me do the math. I know y'all are tired of me saying that. So 12 times 7,200, so 86,400. Divide by 147, divide by 147, x equals 587 beans, red beans. So if I calculated that there was 12 in this area, then I can say that there are 587 in an area of 7,200. All right? So let's say, if I personally counted 320 beans for my actual population, what is my percent error? Meaning, how far off was this sample? Okay, so my actual, this is my formula. So percent error is actual minus experimental divided by actual times 100. So my actual is 320, because that's how many I actually counted, minus my experimental, which would be 587. And I'm going to divide that by my actual. All of that is going to be multiplied by 100. So, doing math. So if I say 320 minus 587, and so I get 267, I'm going to divide that by 320. So I get 83. So it would be negative 83% error. But it's going to be an absolute value, so it's just going to be 83% error, meaning it's really, really far off. So why do we think that our calculations would be so far off? Part of that is because our quadrant size was really small. So if our quadrant was much larger, we would get a more accurate number. So if you redid this experiment, how big do you think you would make your quadrant? The square that I was throwing, how big would you make that? Just think about that. I would make mine much larger because it would be able to count a larger area. But you don't want it to be too big, or then you're wasting your time just doing the quadrant sampling. So the types of organisms we use this on are normally animals that don't move very much, because I can easily throw a quadrant and catch things like coral or like sea stars, things that don't move very much. But if I tried to do this on like dolphins, I'm gonna throw it and they're just gonna swim away. So we wouldn't do this on things that move a lot. They did it on the elephants because elephants don't really move a lot. They just graze a lot. But they were also doing a moving transect line, so that's the difference between that and our little quadrant that we're doing. They use this a lot in the ocean, and they also use this a lot for like plants and things that don't move. So, hopefully that answers most of your questions. And so today today, the goal for today is to complete this data table if you haven't already. You're doing the Bellwork, then you're going to do this application of the quadrant method based off what I've just told you. This shouldn't take you very long. And then I'm going to put a little video of the mark and recapture because it's very important that you understand the concept behind this before you watch the video of the lab for the second part of the lab. All right, so it seems like there's a lot on that one thing on Google Classroom, but it's just all the different parts of one lab. Sorry. That's it. Bye, guys.